This is not going to be in the book.
Okay. Thanks everyone for joining us once again for, I think it's question 3 today, right, Sean?
Yep.
Yeah. So, what do you have for me, Sean?
All right. So this is going to be a system design question.
So I think I might need a few pointers on how to approach these questions.
Sure. So for system design, it's the interviewer is more. It's going to try to think of your, try to test your thinking process instead of trying to get the best answer. So often it's design. There is no best answer, and there's only trade-offs. So it's important to talk about, oh, am I spending a lot on memory, or am I prioritizing time?
Okay.
A lot of the emphasis will be on really hashing out the constraints and use case of a certain design before you start to implement it, and being able to talk about what are the downsides of doing making a certain decision versus another.
Okay.
So what I would do to approach these problems is 4 steps. So number 1, constraints and use cases. That would just be, figure out who's using it, hashing out all the questions that you have available for the requirements of this design. So this will be a very real-life application. So think about memory, think about speed, internet speed. Number 2 is your abstract design. So actually drawing out your service layers. So this will be the main components or architecture of your design.
Okay.
The third one would be identifying the bottlenecks of your abstract design. Think about where a point has a single point of failure. Is the database too slow? What can you do about it? Think about the complexity and the budget. And the last step is scaling your abstract design. So actually, once you've identified it, what method or what can you do to tackle these problems?
Okay.
Yeah.
Sounds interesting. Sounds like a good challenge. So, yeah.
Yep. So this will be a little bit new from your typical.
I don't think I've covered that yet, but I'm ready for the challenge.
All right, great. That's good to hear. So your question today is: design me a URL shortening service like Bitly. So just kind of going through the following the steps, I think would be a good place to start. But you can do it however you want, as long as you hit the process. I feel like that's fine.
So, I assume one example would be given a URL. I would have to. Okay, so let's say a URL, the format that I'm given it is something like this, right? The first part would be the maybe HTTP or HTTPS, and then I would have so the subdomain. And then the domain. I think that's the right term for that, right? Or, anyway, so there are these parts, and then there's other stuff. And I want to shorten it so that, well, it would point to, let's say, so a very So let's say I would point it to something like that, right? So
Mhm.
.com or whatever, and then this is what I'm interested in, right? So this is the part that refers to whatever URL I fed in, right?
Yep.
Okay. So essentially, I'm taking all this. Let's change the color. Taking all this, or maybe not all of it, but like, and I'm storing it into this identifier here, which should be, I'm guessing it should have a certain length. It wouldn't make sense for it to be too long.
Right.
So let's say it should be 6 characters. Or it depends. Let's see. Yeah, so 6, let's say, or let's not determine that yet. So that's n characters. So I want to ask a few questions.
Sure.
How many URLs are we expected to shorten? How many URLs do we have? How many users are there?
Let's say that the service would interface Twitter. So when you tweet a URL, Twitter shortens it for you.
Yeah. Okay.
Let's say Twitter decide to call you up and it's like, hey, I want to only use your URL service for shortening all of our links that people tweet on the internet.
How do we have to keep these links, these shortened URLs active? I assume we do, right? Because like we can't just have them expire after a certain time. So let's say we keep them permanently, or at least for
if you can,
a year,
for as long
right?
as you.
As long as possible.
Let's say 5 years.
5 years, okay.
Yeah.
And then, and I assume if it's like Twitter, then we would have at least like millions of users. And then I guess, let's say everyone posts at least one link a day. So that's like, you know, a million more, like millions of links per day. So we would have to look at the storage as well. So how much space we would need, and how much space we would need, and how to make that storage more efficient. So okay. So let's see. So 5 years, let's say 5 years, and that's times 365 days a year, times, let's say, 1 million, 1 million links to store per day. What is that? Do I get access to a calculator?
Sure, yeah.
Okay, so I'm just gonna 5 times 365. So that's just 1,825,000,000. Right? 1,825.
Okay, let's round that number if we can.
So let's say 2 billion then. Let's round that to 2 billion.
Okay.
Make that easier. 2. Okay. 2 billion. So we want to be able to store 2 billion URLs at any given time. how long would the URLs be expect? How long do we expect the URLs given to be? Is there a limit for that? Maybe like a certain number of characters. I assume. Twitter has a one. Oh, sorry.
Oh, go ahead.
Well, Twitter has a 140 character limit, right? Something like that. So let's say it can't be more than that.
Well, Twitter will be shortening it itself, so you can actually go longer than that, and they'll shorten the link for you. Let's say there's no more than 500 characters per link.
Okay.
Yeah.
And I guess we also want this. We also want this link part to be as short as possible to make it useful.
Yep.
And so, assuming we can only have, okay, so let's see like what the length of this thing has to be, like the minimum length. So let's see what characters we can use in this link. So let's say we can use any of the lowercase letters, and also so that's like 26 of them, and the 26 uppercase letters. Let's say these are treated differently, plus the digits, so 0 to 9, so that's 10 digits. Let's see if there are any other things we could use in our URL. So ideally, we want this to be the things we can use to be. We want to be able to use more things so that we can actually we don't have to use that many characters in the URL. So let's say, can I add anything else to this combination? So I wouldn't use the symbols because those might be interpreted in unpredictable ways sometimes. So let's just say let's just say we're gonna have 62, right? 62 possible characters to choose from. And in order to get a combination, like a link like this, to represent each of the one unique one to represent each of the 2 billion possible items, we would have to, well, this thing would have to be of a length at least, and let's see what the formula is. Well, it would be 62, well, 62 to the power of, well, 62 times 62 times all the way to something for a certain number of 62s would be this number, 2 billion, right?
So, let's assume 6 for that.
6.
Yeah,
well, I was gonna say 62 to the power of something is 2 billion. So I was gonna just solve it for for that.
Okay, that's fine too.
So I don't mind using. Okay, but let's see. So that would be, well, log base of. And I guess I need to review my math to find out how to solve this, base of 2 billion.
So you're trying to figure out what base to use 62 as?
Well, I know there are 62. I'm trying to figure out like the possible. Well, I know the number of permutations I want. That's 2 billion.
Right.
And I know how many different characters I can use at 62. Mm-hmm. So I just want to know like how many, like what the length of that string is for me to get 2 billion permutations.
Oh, it is 6.
6. Okay, let's.
Yeah, 6 is the minimum. So.
Okay, so let's assume I solve this because I don't remember how to do that. So let's say n is 6.
Yeah.
And okay, so we figured out the length of this identifier is 6 characters.
Yep.
All right, now let's look at other constraints. Or the design of it actually. So so let's say the front end of this is well, it does it automatically. You don't need to know. You don't as in Twitter, right? Like Twitter. So.
Yep. So this will be a API service.
Okay.
Instead of a full-blown website.
So the front end part, I don't have to think about here. I just need to think about the API.
Yep.
Calls to the server and how this is stored. So. So let's see. Let's fix where I draw this. So there's an API here, and that communicates with the database. I don't know why people draw this whenever they think of database, but database. What kind of data, like what would I use for this database? Let's see, so it's one-to-one mapping of, it's a one-to-one mapping of the 6-character identifier to the actual URL, right? So, and I want to be able to quickly access this. I want to, given the 6-character ID, I want to be able to retrieve the URL straight away. So I think I want to be able to retrieve it right away. Could I rely on caching for that, or some kind of caching?
You could, if you would like to. Yep.
Because, so, one concern I have if I do this is, oh right, also I need to talk about how much storage we'll need, right? We did?
Yeah.
I forgot about that. So 500 characters per link. So let's assume the max, right? 500 characters per link, and 6 characters.
Yep.
So each character, let's say each character is stored as a, let's see, so how many bytes per character? how many bytes per character? Let's see.
Is that a question for me?
No,
Okay.
I'm saying I don't know, so I'm gonna. Oh, so okay, so it depends on. Yeah, I guess I'm cheating right now. Depends on what kind of encoding it is, right? So this, let's say we're doing this in for common URLs, we don't need any sort of we won't use any sort of special characters. So let's say if it's but maybe I don't know. Are we using Unicode or ASCII? Let's see.
Let's use ASCII.
Okay, so that would be just 1 byte per character if it's 8-bit ASCII.
Mm-hmm.
So 1 byte per character, so that's 500 bytes per a link, right? 500 bytes per link. And also we would have to consider the ID itself. So this, let's see. So 500 bytes times 2 billion entries. So that is okay, let's do some math. So this is 1 trillion bytes, which would be so bytes divided by there are 1024 bytes in a kilobyte, right? And then 1024 kilobytes in a megabyte. And
Yes.
so forth. So I'm just gonna instead of doing the math, I'm just gonna actually I should do the math. So so let's see, 1 trillion divided by, so let's convert this to KB, and then convert this to MB, and then convert this to GB. Oh, okay, so do you see what I'm doing here?
Where are you on the page?
I'm in the URL bar, so 1 trillion divided by 1024. So that's bytes, convert that to KB, convert that to MB, and then finally to GB.
Mm-hmm.
And so I think I have the math right. Correct me if I'm wrong, but I have about 930 GB. And that,
GB?
I think so, yeah. So
okay.
That's close to 1 TB, less than 1 TB. So let's just say.
So let's round that number, so it's
so
easy to work with.
Rounded, it would be 1 TB of storage for the links, and also for the 6 characters, the IDs. Actually, 6 times 2 billion, so 12 billion. 12 billion divided. So convert that to KB, convert that to MB, convert that to GB. Okay, so that's actually just 11 GB for the IDs. So I think together it would be just 1 TB or even less than that. So let's say storage, in terms of storage, we would need 1 TB at any time. Let's see, what else do we need to cover? many calls to the API do we expect per day? Right. So given that we have 1 million users, let's assume they're not going to be posting. Let's say they post one link per day, even though that's probably most users post more than that. So, but let's say one link per day, for simplicity's sake.
Okay.
And I'm gonna assume these posts are spread out evenly, also to make things easier. So let's say 1 million per day. 1 million. Divide that over 24 hours. Divide that over. Okay, 1 million. 24 hours a day. Divide that over 60 minutes per hour, and we get. Okay, let's see how much per second actually. So like 11 links per second. Here I do 1 million conversions per day, divided by the hours in 1 day, divided by the number of minutes in 1 hour and the number of seconds in 1 minute. So that's 11. So let's say that's 12. 12 links per 12 new links
per second. Okay.
And this is only conversion, right? And we also want to look at access of existing links. So that itself wouldn't take up more space, but that would also require some computational work, basically retrieval. So let's say, what's a reasonable number for let's say each link that gets posted, that gets converted, is accessed 100 times. So 100. How many links? We said we had 2 billion links, right? At any given time.
Yep.
And that would be 200 billion. Acts, 200 billion calls spread out over a time span of 5 years. 5 years. So 200 billion calls, and this is another matter of simple math. 200 billion calls in 5 years. How many per second? So 200 billion divide by 5, so that's this amount per year, and this amount per day, and this per hour. Divide that by 60 minutes, and then 60 seconds finally, and we have 1,268, or let's say 1,300, around 1,300 calls per second. This is just accessing the record. So we would have to design design it so that it can handle this traffic. So the database itself, I think we are looking at something that, well, it's definitely, we definitely need multi-threading of some sort, I think.
Mm-hmm.
Right, multiple processes running at the same time. And actually here, this is where I'm stuck, because I don't think I
Okay.
know enough to talk about this.
Got it. What database would you use?
So it has to be something persistent, because it's not just processed once and thrown away. So it has to be something that we can store permanently, let's say, or like semi-permanently. But then it has to be something that we can access quite quickly. So when we access it, I'm gonna say when we access a certain element, we're gonna cache it. So to make the subsequent accesses easier.
Okay.
But to store it, maybe something like a SQL database.
Mm-hmm. Okay. I think that works.
Huh?
I think that works.
Yeah. So a SQL database, something using SQL. Yep, I am.
Okay, so let's let's see. I'm gonna draw two lines on below of your 1 terabyte DB and API chart.
Okay.
And you can just draw the services within each layer. So I just do here you can say it's like this is the internet.
Mm-hmm.
I'm using my mouse already.
That's fine. I'll write it for
you. Thanks.
So internet.
Yep, and below that internet line is your server. Now we have.
Wait, you mean if I ignore the stuff above?
Oh yeah,
right?
ignore the stuff above.
This is a new model.
Yes.
Okay. So this is okay. So this is the server.
Yep.
Okay.
What modules would you see in your server? Modules or components.
So the database, that would be maybe, let's say it's a SQL database, and then we would need something to access the database. So I guess this is the API is here. Maybe there would be some Java component
Mm-hmm.
that communicates with the database, and it would send it queries, and the database would return the the link, the link corresponding to an ID.
Okay.
So basically, when the API is called, I don't know if this API is actually this component here. I think maybe
It could be, right?
let me think. Yeah. So these. So these. Okay. So. Oh, my bad. So that component just now, I might be able to just say this is like this big Java application.
Mm-hmm.
And so what happens is, oh, so I guess before the Java application there might be uh, some listener, right?
Mm-hmm.
Uh, well, I'm going to walk through it to see if I can figure it out.
Sure. Okay.
So calls got made to the API as like this. And then what happens is the something parses the command. So the call to the API, it might be a let's say it would be in a JSON format or Ajax or something similar. And so
Okay.
basically, so let's say JSON, and this API would look at the query and parse it and see if it makes sense. So
Mm-hmm.
if it does make sense, it gets thrown to the Java application where specific functions are called, and then when the function is called, it makes a call to the database here. Say, for example, maybe it might be like select from some something where the ID is equal to this string, this 6-character string, and then see the database returns either it's found something or it hasn't, and if it's found something, then it returns it to the application, which in turn returns it to the API, which in turn returns it to whatever called the API. So it would be, yeah,
Okay. So how many services should be within your Java application?
I really don't know.
Okay. So how many different tasks does your Java app do? Just in terms of types.
So let's say it. Okay. So let's say we have a get. So the key thing is, let's say string actual URL,
Mm-hmm.
and you're giving it a string ID, right? And
Mm-hmm. So this is a return me a redirection kind of service, right?
Right. So I guess we're not just
So your app is doing two things. One is uh, given a long URL, convert it to some short URL.
Oh, right.
Yeah.
Yeah, I completely forgot about that. So this
Yeah.
is only about accessing. There's also converting. So it can also take in, or actually it wouldn't be. It would be saving that.
Mm.
Oh, right. So it would still return the new ID if you're given string proper URL. And what this does is it takes in a proper URL and it goes through the checks whether it's proper. If it is, then you do you store it in the SQL database, and the SQL database should give you a unique ID for that.
Yeah.
And then you return that ID back to the API to return to the user, so they know what their new URL is.
Mm-hmm. Yeah. So given these two, it'd be helpful to just draw like two boxes in the Java app that you have, and to say like, oh, this use case is the conversion, and then this use case is the retrieval for the URL.
Like this?
Yeah. Yep.
And then, so the arrows would still, with this.
Yeah.
Okay.
Cool. So that is one design. How can you optimize this design?
So let's see. So
think about
some
time.
Right?
Think about security. Think about your server staying up.
You said
I guess this is called reliability.
Oh, okay. So let's talk about time first. So time, I want my users to be able to store their URLs and also to fetch the URLs as quickly as possible. So perhaps I could have multiple instances of this application. So this is another instance running, and the API would determine which applications are available, and it would send the request there instead of continuously sending it to just one instance of the application. So that would.
There's a term for a program that determines which version of an app. What is that called?
Modem?
Do you know?
Modem? No. Router.
A more conceptual term. Okay, so that's called a load balancer.
Switch or. Alright, I'm just throwing out terms here.
Yeah, that's okay.
I don't know it.
Okay, so the term is the load balancer.
Oh, okay. load balancing.
Yeah.
So this would be part of this would be one additional component before the Java application or the application.
Correct.
Okay, so let's say we have a load balancer here. Yeah, this isn't working very well. Load balancing.
Mm-hmm.
So that having this would speed up the access time if there are multiple or many calls to the service at one time.
Mm-hmm.
The trade-off is you have more. You would have to use more memory because you're running multiple instances of this application, and if there aren't that many calls to the API to this server, then you're using extra space and extra computational power for nothing.
Mm-hmm.
For no benefit, right?
Yeah.
And then let's see. So time. We've improved the speed of this. Security. So we would want to make. Oh, sorry.
No, go ahead.
So I think we might need we would have to validate the input that we receive to make sure that it's not malicious in any way. So I guess I've assumed that it was already implemented, but then we would probably want to make sure that we don't get URLs that are like that try to imitate SQL commands. So maybe like it would be part of the URL, and then it would end the command and then say delete drop all from the table, right? That would be
right.
I think it's called injection or something. So we would
code injection.
Yeah, code injection.
Or SQL injections.
So we would want to check to make sure there aren't any. Well, we would want to clean the input, right? We want to clean the input before it goes to the database. So this would happen in the application, I think. Yeah.
Yeah. So currently, as it is now, your two Java programs or apps.
I'm gonna say there are multiple Java programs running.
Sure. Okay.
So,
are they all on one machine?
Okay. So I think what you're trying to hint at is I should have them on different machines. So basically, in that case, the database. So the database itself, SQL database. How do I want to move this part, but I guess it's so. Let me try doing this. I'm trying to grab this part here and move it somewhere else.
No, is it working?
I don't think it works this way. So,
okay.
Okay, so I guess the SQL, the database would be on one big server, one big machine, and then okay, so I guess we could implement it in different ways. One would be to do everything on one machine, and the trade-off of that is, well, it should be faster, but then if the machine goes down or if there's any maintenance required, then the service is going to be down for however long it takes to repair
Yeah.
stuff. So if you have it separated on different machines, I think what you would want to do is you have different machines with the application. I'm sorry, my drawings are horrible, but so you have different machines with the application, and they would communicate with the main machine with the database. And then also I would want to have backups. So I think I can do regular backups of the database. Sorry. Okay, so it's regular backups of the database with the stuff stored on the data stored on another machine. So
cool.
I don't know.
So what would you do if that one server failed, or one database failed? Let's say it's like 4 a.m. in the morning, and you get a notification saying from your Java program, it's like, hey, I can't find this database.
I guess I would have to redirect them to the backup.
Okay.
For the time being, and try to. But then, what the problem with that is that anything not backed up after the last backup wouldn't be accessible, so it would be lost.
Yeah.
So
there's a structure in at least databases called master-slave, where a master continually updates to make sure it's in sync with several slave databases. So you can assume that, I guess, most of the slaves on the bottom of the master are just going to be up to date.
Okay, so they're gonna. Oh, so what the master does is it keeps, whenever it's updated, it will update the other slaves.
Yep.
Interesting. Okay.
So masters accept read and writes, but slaves only accept reads. So the Java programs can also read from the slaves, but can't write to the slave.
So actually, the Java program doesn't have to just talk to the master, it can talk to any slave.
Yeah.
But it can only read from the slave, it can't write to the slave. That makes sense.
Let's see, I think you're approaching the end of this. What about, so let's say...
Oh, I also had thought of one other thing. So,
sure.
This would be vulnerable to, I guess, a denial of service attack. If, say, we
Okay.
receive too many calls to the API, it wouldn't be able to handle it. So I guess so I don't know how to handle actually, but I think,
well, let's not do a DDoS right now or DOS. Let's just assume, Justin Bieber tweets something very controversial, or Trump tweets something very controversial with a link on it, and all of a sudden you have a surge of users coming in, a very high spike of users who want to get the conversion for an ID. How would you handle that spike in requests?
They want the actual URL for an ID, so they're.
Yep. So the URL's already converted. I think you touched on this a little bit earlier.
Yeah. So if I have multiple instances of the application, then I guess the load would be balanced between these instances, these Java instances. But assuming that that's not enough, then we would have to create more.
Okay.
And so I think the load balancer might be able to create more instances of the application, and let's assume that there are a few machines there for this purpose and they're not used.
Yep.
So the load balancer would create more instances of this application on these different machines, which would in turn access the multiple databases, and they might not. Okay, so my computer's being weird right now. I think it's because So I was saying they would not just access the master database; they would also access the slave databases, and because it's only a read operation, it's completely possible. So it's not like. But if they were trying, if people were trying to write to the database, if they were trying to convert links all at the same time, then we might have a problem where like the bottleneck would be at the master database.
Okay, so for every request I want.
I thought of one more thing. So you were saying
sure.
It's something that maybe Trump shared, right? But then maybe it's all pointing to the same thing. So we wouldn't want to convert the same URL every single time. If it already exists, we would want to give it the same ID. And we would be able to do this from another. So this would actually be, this would go back to our Java application command. So like when we get the ID, we would be first checking in the database to see whether that URL has been stored. And if it has, then we just return the corresponding ID.
Can you repeat that again? Sorry.
So every time every time we call on every time we call on this new ID function, we don't actually tell the database to create it just yet. We make a call to the database to see if this URL is already stored. If it is, then we return the corresponding ID. If not, then we create, or the database will know what ID to create and return that ID. And also, yeah, so. So I don't know. You were saying something before. Right?
Okay, so, right, so you have, let's say per second, thousands of requests.
Sorry,
right?
Sean. Give me a second again. I'm at 4%.
Oh, are you getting your charger?
Yeah, I should probably plug it in next time.
Yeah, let me know when you're done.